Hey guys, I hope you're well. This is a little electronics test. This is the schematic diagram for my aquarium auto top-off controller. It's completed and on the system and running, and man, this thing works beautifully, except for one problem. It operates beautifully, but there's one thing that drove me nuts. And here's a hint. It has to do with the LED function. Okay? I'm not going to say yet what. Oh, yes, I will too. Here's an electronics test. When it was full, okay, here's how it operates. When it's in a ready mode, the green ready LED illuminates. It's ready for a fill. When the bottom sensor detects the magnet, it knows that it needs RO water. It turns on this relay, and as long as the switch is closed for the 2 sensor mode, it latches on. The water starts filling and filling and filling until it activates this Hall effect sensor, at which point, excuse me, this base is taken toward ground, turning this transistor off. Okay, it's full now. When this transistor turns off, it resets this latching valve control relay, okay, turning off the valve. Here's the problem. Should I tell you what the problem is or not? If you'd like to take a guess at what the problem, I don't know, let's screw with all that. Do I tell you or not? Okay, I'll tell you. When it reached a full condition and this blue full LED came on, the green ready LED stayed on. I did not want that. I did not want that. It's either full, it's ready, or filling. The filling LED is orange. I'm going to zoom you in a little. Hang on. There we go. The filling LED is orange. I don't want 2 LEDs on at the same time. It's either full, it's ready, or filling. And when it reached its full condition, like I said, the green LED stayed lit, even though this transistor was open. When this transistor is turned on, the emitter is brought to near 12 volts, supplying power to this relay. That's how it works. That's how it resets the latch. Turns the transistor on when it's full. This point floats, turns this off. This point floats, but the green ready LED stayed on. Why? That's your first question. Question A. Why did the ready LED, the green one, stay lit when Q1 turned off? Okay, that's question number 1. Question number 2. I had to remedy this situation if possible. Now, I didn't want to disassemble my unit. It was completed. It was a nightmare to mount the jacks. They're junk. But I managed to get enough good ones out of a order of 10. Never again will I buy from Amazon. Not electronic parts, not electromechanical. Nope. Nope. It'll be Mauser DigiKey from now on. So back to the questions. Why does the green ready LED stay lit even though Q1 turns off? Question number 2. If I break this connection right here, right? Easy enough to do without disassembling the unit. Either you'll see why when you see how I built it. I used a board, a proto board, made for this purpose. It's basically laid out like your proto board, your plug-in proto board. So you basically transfer it over, right? So it's easier to break this connection to the anode of this LED, which I did. Now I'm going to pause you and zoom you in again. There we go. After we break this connection to the anode of this LED, my first question was to myself, I wondered, is there a point in this circuit where I could connect that anode so that when the blue full LED comes on, the anode loses power, that green LED turns off. When it's no longer full and transistor Q1 switches on, energizing the relay, it's got to be off. When the valves, it can only be on in one condition. The valve is not filling and it is no longer full. The top sensor, the full sensor, is no longer active. Transistor Q1 is turned on, allowing the valve control to function. It's ready. Is there somewhere in this circuit where I can connect the anode of that LED so that when it's full, the ready LED is off? When it's no longer full and in a ready state, the ready LED is on. When the magnet float reaches the bottom sensor, indicating a need for water, the relay latches on, starts filling the valve. The orange filling LED comes on. This better be off. One moment. I pause you. That wasn't bad, was it? I pause you. I miss Philippe. I'll have to tell you the story about Philippe sometime. You won't believe it. You just won't believe it. Well, that's the schematic. Works a treat. Now that only one LED can be lit at a time. Where are you going to connect the anode of that LED? I hope you're well. I may add on a little help and welfare update on the end of this. So if you're not interested in any of that, thanks for watching. I hope you're well. I hope you have a great 2024. I plan to, regardless of the challenges. I'm going to have a good time. Especially learning to fly my new drone. Oh my God. I'm an RC airplane pilot of yesteryear, and the muscle memory is hard to break. I suppose it'd be quite the same going from an iambic set of paddles to a bug. Yeah, I know, not happening in this chat. I hope you're well, guys. I'll catch you later, and I'll be back. And I think I'm going to do a health and welfare update now. So if you're interested, stay tuned. Hey, guys. Okay, guys, the answers. Before I get to the health and welfare update, the answer to my questions. One of the answers I'm not so sure of, and it's this. When this sensor detects the magnet, it's full. It turns this transistor off. The emitter goes to a float condition. Yet the LED stays lit. It's obviously getting a source of positive voltage. I tipped you. From somewhere. It's getting power from somewhere. Where? It's not this emitter circuit. Well, it's obviously getting it through the relay coil, right? The problem is it shouldn't be lit because it's any positive source over here is stopped by this reverse bias diode. It shouldn't be lit when it's full, yet it is. Well, at this point, I quit trying to figure out why it's lit and turned my attention to what can I do to stop it from being lit. I broke this connection, and the first thing I tried was to tie the anode to this point here, and it didn't help. Let me say that these LEDs, they're new, they're exceedingly sensitive and efficient. Old school LEDs took at least 10 mils and preferably 15 mils to light them to full brightness, not these. Give these guys a couple milliamps and they'll light. And they'll light fairly bright too. Well, when I first connected the anode to here, it didn't help. And I looked at the schematic here and I realized, believe it or not, it's getting its source of positive voltage through this pull-up resistor right here that you have to have for this Hall effect sensor. So that didn't work. I wondered, where might I hook it else? Now remember, when it is in a ready condition, it'll be lit. When it's filling, I tied it right here. And I wondered, well, will that work? And it will. When it's ready, in a ready condition, this anode gets full voltage. When it's filling, you want this to go off. This point of this relay goes to near ground when it's filling, right? Through these diodes, through this relay contact to ground when it's filling. And so if I tie the anode here, when it's filling, the ready LED will be off, like I want. And yeah, what about when it's in a full condition? Well, when it's in a full condition, and if I tie the anode here, this Hall effect sensor is off. And you do have this pull-up resistor, but it's reverse biased and stopping the source of positive voltage. I think I could have said this in a lot fewer words. When it's in a full condition, the ready LED is off because of this reverse bias diode. When it's in a filling condition, the ready LED is off because it's tied to here, effectively taking the anode to ground. And when it's ready, it's on, fulfilling my wishes. You tie it here. Break this connection, tie it here. Easy enough to do on the protoboards. Just heated this pad, pulled this wire out, and I tacked it onto this one of these pads on the protoboard, and it works beautifully. The system's done. You want to take a quick look at it? Hang on. And so there you go. We're under the aquarium. Let me turn this. There you go. That's it. That's it. Oh, this is difficult. I keep hitting the stop button. That's it. My autocontroller. I'll explain its function and show its operation in a future video. Bye, guys. And I'm back. I just can't seem to shut up today. I'm in the mood to bullshit electronics. Advanced troubleshooting. Advanced topics. Question. My problem and my mystery was when this LED is full and lit, when it's full and this LED is lit and this transistor is turned off, when I had it connected here, this LED was still lit, right? I assumed through the relay coil resistance. But the thing is, it should have been stopped. Any source of positive voltage should have been stopped by this reverse bias diode, and yet it was lit. And that's when I decided to stop trying to figure out why and find a solution. And I found that by tying the anode to here instead, it satisfied my requirement of only one LED being lit at a time. When it was full, remember that was always the problem area. When it was full and this transistor's turned off, it was still lit. Well, tying it to here solved the problem, but it shouldn't have. The question is, why did it solve the problem? And also, it begs the question, where was this LED getting its source of positive voltage? Even though this transistor's off and this diode's reverse biased, it's getting it somewhere. Can you think of what might be the problem? With explanation of why tying the anode here solved the problem when it really shouldn't have made any difference. Why shouldn't it have made any difference? Again, this diode's reverse biased. Any source of positive voltage over here should be stopped. And this emitter was floating. It shouldn't have been able to be lit, but it was. And there's a reason. I've been sitting here thinking about it. Why would tying the anode here solve the problem? And can you think of a reason why? I'll let you think for a minute. While you're thinking, let me start to explain what I think is going on here. I'm going to leave it because it worked great, works a treat. Tying the anode here solved my problem and satisfied my requirement of one LED being lit at a time. And yet, it bugged me. Let me say this. In early testing, I threw my voltmeter across the collector and emitter to verify that Q1 was in fact being fully turned on and pretty much all fully turned off. It was easy to make it fully turn off. It wasn't quite as easy to make it, to bring this emitter up to near 12 volts when it was turned on. Because what you're using it in a common collector configuration, not a common emitter configuration, which provides the most gain. You have far less gain in a common collector configuration, as you know. Well, early on in testing, yeah, it was. I verified it, and I chose a base. This resistor driving the base. I chose a value that provided that condition, that this emitter was being pulled up to near 12 volts. And then I got on with my testing and my building, and, one thing led to another. Well, I never redid that test after coming up with this final configuration, this final circuit, if you will. I never re-verified that. And what I think was going on was that when this emitter should have been floating, when this transistor's turned off and this emitter should have been floating, I think maybe it wasn't floating. No, I think it was not getting its positive voltage and current source through the relay resistance. No, because of this reverse bias diode. I think this transistor wasn't being fully turned off. I think I'd find, and remember, like I said, these LEDs are extremely efficient. It's amazing. And this transistor wouldn't have to be, and especially why would it solve my problem by tying it here, though? Well, simple. If this transistor is not fully turning off, allowing this LED to stay lit here because of its extreme efficiency and sensitivity. Boy, adding this, I don't know how many thousand ohms this relay coil is. Hang on, I pause you, I'll figure it. Okay, not as many ohms as I thought, not as much resistance as I thought, only 250 ohms. Because it's a 50 milliamp 12 volt coil. Well, tiny anode here, apparently adding that, and this is the only thing I can think of as to why it solved my problem. Tying the anode here now puts this 240 ohm resistance in series with this partially turned off or mostly turned off transistor, stopping the LED from being lit when this is. It's the only thing I can think of. It is, truly, because of this reverse bias diode. Everything below the stick doesn't exist because of it when it's in a full condition. Only those parts above it. And well, it's not getting when this is off, this LED is not getting its power from a dead cap. It's not getting its power from a diode. It can only be getting its source of current from this transistor. Agreed? Other suggestions? What say you? I hope you're well. I'll catch you later. From Blipsy and I. Take care. Bye, guys.